Good morning, everyone. For today, I want to talk about inheritance with C++. Today, we talk about inheritance. Hopefully, we have the opportunity to talk also about operators, an extra set of operators. The goal is between today and the next lecture, finish with C++, and therefore moving to our next language that is going to be Lisp. So if everything works, next lecture is going to open your next quiz and your next assignment. The next assignment, programming with C++. The next quiz, a quiz about C++. And you're going to have 1 week to work as usual. So next Tuesday, probably, if we finish, you're going to have homework, a quiz, and programming if you want to start reviewing things. Good? So, inheritance. There is nothing new about inheritance. You already know from your Java knowledge about this idea of the parent and the child. Usually, the notation in Java is to talk about the parent and the child. We use that reference in Java. In C++, what you are going to find is they call the superclass and the subclass. The superclass is what today we call the parent, usually a reference that Java proposed, and the subclass is the child. This is what we call the child class. But if you read a book about C++, the concepts are going to be the superclass and the subclass. Superclass, the parent, subclass, the child. Just in case you read something about it, these are the concepts. The same, use different ways to call them. Now, another way to do this in C++ also, some people call, instead of the superclass, the base, and instead of the subclass, the derived class. That is kind of a modern way to do things. So parent in Java, C++ 80s superclass, C++ today mostly base class, child, subclass, or derived class. Names that we're going to be using. The most important thing here is when we talk about inheritance in C++, C++ allows you to have more than one parent. In Java, you can only use extend and extend from one class. So in Java, you can only have each child have only one parent, or each subclass have only one superclass, or each derived class have only one base. Excuse me. When we talk about C++, you can have as many as you want. Multiple inheritance. And I am going to show you an example. But that is the main difference. Only one or several. Several C++. Only one Java. Now, an example. As we did before, we can put one class or more in only one file, or I can have two files, up to you. In this case, I am using the class with all the methods inside. I have a class base. I am going to have only methods, so everything is going to be public. The constructor, one method, whatever, the destructor. Now you're familiar with the builder. Destructor, constructor, and one method. Everything there, simple, one parameter, cout, end L, we talked about that before. Only printing messages. And the only thing that I want to show you is what happened with this method, how to call the method. So nothing fancy happening there. The other class, the only new thing, inheritance, colon. No extends, not implements. You want to do inheritance. The name of the class that is going to be the child, the derived class. The name of the class that is going to be the parent, the superclass, the base class. Simple. The only new thing here. One thing is that I have this public, like in the other class, and that one make public these two methods, the constructor and the destructor. And a new thing now is I can put public, private, or protected for the inheritance. What is going to happen? Well, number one, here, you can put nothing, and we talk about this by default is public. So usually, if you're going to do that, you can use colon, the child, and the parent. But if you want to use the keywords have a particular goal. The goal, I summarize that in this table. Think about this. You have the parent, and in the parent, you have things that could be public, private, or protected. This is the parent. This is the base class, the original one. When you do inheritance like you did in Java, when you do inheritance public, like I am doing here, again, is the default. When you do in the inheritance this, what is going to happen is the same thing that happened in Java. Everything that you have public in the parent, you are going to have that in the child, and it's going to be public. If you have a method that is public in the parent, and you inherit that method to another class, this method is still public in the child. You can create an object from parent or an object from the child, and both objects have access to that method is public. It doesn't matter that it's not yours that you are inheriting. It's public inside of you. If you have something that is protected in Java or here, protected means that is not public, cannot be accessed from outside, but protected means that is public for the family. Protected means that you have the method here, and if you create a child, this one have access to the method. But if this one have more family, more childs, all of them are going to have access to the method. That is the meaning of protected. If you do public inheritance, whatever is protected in the parent, when you inherit, it's like it's yours and it's still protected. That is Java. That is something that you already test there. It's working here in the same way. What happens if I have private in the parent? A very common error in your exam, guys. If you have something that is private in the parent and you do public inheritance, just because public, protected, a common error is to think that if I have something private in the parent, it's going to be also private in the child. If you have something that is private in the parent, you do not have that in the child. It's private. When something is private, only this class have access. If something is private there, it's not going to go down. That is the reason of the protected. A very small difference, right? Be careful with that. Family, protected. Only mine, private. inheritance, public. Almost the same that Java, almost. Easy. Moving forward, really the important thing is what happened if here, instead of public, I put protected, or worst case scenario, if I put private. Well, what happened if here I put protected for inheritance? Easy. Anything that is public in the parent, when you do inheritance and put protected there, all the public things are going to become protected. Protected? Yeah. All these methods that I have in the example here, this one, for instance, is public here. And if I put here protected, that method is like, it's going to be here, but protected, which means that I can use it. My child can use it, but from the outside, no one can call that method for an object of this particular type. So you are telling me that in Java, you have something that is public and the inheritance make that something to continue being public in all the family. Because the method was public in the parent, all the family inherit that, and that method is public in all the childs. Any object from any member of the family can be used to call that method because it's public, because it's in the parent. Now, for C++, you can have something public in the parent, but you can use inheritance and stop that something from being public in your child classes. It's public from this point and above, but I am doing that method public, now is protected or private. I can change the scope of the things that I am inheriting. And that is the key idea with this public, private, or protected inheritance. Anyway, if something was public and I make the inheritance protected, that something is going to become protected. If something was already protected and I make protected inheritance, it's going to be protected still. Nothing changed. The only change was for the public. Obviously, if something is private, I do not have access. Public inheritance. I inherit everything with the same denomination except private. Protected inheritance. The public things become protected. Everything else, the same. Worst case scenario, if I make private inheritance. If I make private the inheritance, what is going to happen is everything that is public in the parent is going to be inherited. But starting with me is now private. All the childs that go down, subclasses of this one, of me, they are not going to have access to this variable or to this method. Public now become private. Protected also become private. Did you notice? If I put a private inheritance, everything become private. And things that was private before, again, if something is private in the parent, I do not have access. Which are the consequences? If I have a class and this class have a method I can create an object and I can use that object to call the method. If I do inheritance, like in Java, I do not need to put the method here. I am inheriting everything. I could create an object from the class and I can call the method. If the method is public in the parent, it's public down. In my source code, obviously, this relationship of inheritance in Java, I have my class A and I am extending B. When I move to C, now I can just do my inheritance with the colon and the behavior could be the same. However, this one is the public inheritance. If I do there, not the default, but private or protected, whatever of those options, this cannot happen. Assuming that this is my main method, I cannot use this print with the object B because in the class B, the method print protected or private, not public anymore. One keyword in that particular place and the family no longer have access to a particular resource. The main difference with the inheritance between Java and C++. Makes sense. Review this table, the parent, the inheritance, the result. Remember this common question in your exam, something like the one that I showed you before. Two classes inheriting, and we ask you if that source code works or not, if something is printed or not, and it's all about understanding what is being inherited. Good? Okay. Moving forward. Now that we're talking about inheritance, well, let's talk about the inheritance of the constructors and the destructors. I show you this, and I put here constructor and destructor in the parent, constructor and destructor in the child. Two classes, base and derivative. Method main, and you can imagine that I am using the previous classes. Main. One object. My PQ1 calling the constructor. That object in the heap or in the stack. Okay, in the stack, right? Thank you. The object is in the stack. The object is from the derivative class. Makes sense that I am calling the constructor. And as you remember, the only thing that I put in the methods are messages. So when I do this line, that message is going to appear. And this message is going to appear. How do you know that those lines are related with the constructor? Well, because after the constructor, I am calling function, and these two are the messages related with function. Function is printing a message, remember? tell me, why is the constructor of the base class being called? I haven't created any object base. Moreover, in my source code, this is the constructor of the derived class. Oh, something is happening there. What is happening? Do you remember what do you do in Java in order to call the constructor of the parent? What do you do in Java if you have a class and that class need to call the constructor parent? Super, thank you. Super. Do we have a super in C++? No. Which is the equivalent of super in C++? This. Do you remember this crazy rule in Java in which if you want to call super, the constructor of the parent, you need to put this super at the first line of the method? But if you forget to put that in the first line, for any reason you put that lines below, Java complain? Why do I need to put an instruction in a particular place inside of the method? It's an instruction. Instruction should be in any place. Well, in order to enforce that, C++ do not have a instruction super. In C++, if you want to call the constructor of the superclass, what you do is when you are creating the constructor for the subclass with the parameters, you put this colon. Notice, this is the colon for the inheritance. The inheritance is happening in the blue line above. But this column here is connecting constructor in the child, calling constructor in the parent. The two constructors connected with the semicolon. That is the replacement in the syntaxes of C++ for your super in Java. That's it. A new crazy notation. Now, that is the reason because, going back to my example, I am calling both. Did you notice the order? Which one is the first to print something? The one in the base. And it's the first one because this call here happens before I start with the body of the method. I am calling the constructor of the derivative, but that one, the first thing that it's doing is to call the constructor in the parent. The first one to finish, the first one to print something is the constructor in the parent. And when that one returns, now I print the message in the constructor derivative. That is the order. That is the order. Base and derivative. Good. Okay, two constructors, and then I call the function 2 times, whatever, to print. And then I do a pointer. Question in your exam. This line is going to print something. That line is calling the constructor of the parent or the constructor of the derivative. Yes or no? And I hope that, thank you, no. That one is a pointer. A pointer is a space for an address. Nothing is happening there. The one that is going to call the constructor with pointers, this one. And again, I am creating an object with a pointer, a derived one. But it's going to call the constructor, and the constructor is going to call the constructor of the parent because I use this replacement of super. And I am going to have these 2 lines. And then I am going to call the method, something that I need you to remember, the dot and the arrow. I am being very persistent in those examples. The dot for the object, the arrow when you are using pointers. 2 messages, 1 per execution. And then what I do, as I show, is because I do a new, I do a delete. And when I do a delete for the pointer, the destructor of the derived object, but also that destructor called the destructor in the base. Yeah. When you call delete, delete call the destructors. And if you are using inheritance, you are calling this destructor, and that one is calling this one. Wait, you do not have anything here. You do not have the colon and something else. For the constructors and destructors, by default, for the constructors and destructors that do not have parameters, those are the default ones, they automatically call each others. By default, that is the rule. That is the way that the things work. The ones that do not have parameters, they automatically call each other. So the child calls the parent. The only reason here, because I am using this super thing, is because I want to send the parameter. That is the only reason, because you use super in Java, right? Because you want to send something, a parameter. But if you do not want to send the parameter, you do not use super. If you do not want to send a parameter, you didn't put this thing inside of the box. Even though you are calling constructors and destructors in the parent. So this one, the derived, print something, call the parent, print something. Very important thing, guys, constructors, which one runs first? I am printing the messages to make clear. Constructor, first one, the parent, and then the child. Destructors. The program finish, this delete finish, call the destructor of the object. The object is derived. The object is going to clean whatever put in the memory, and then it's going to ask the parent to do the same. Remember, even though you think that derived inherits something from the parent, derived is only responsible of the things that he or she creates. It's going to ask the parent to clean the things that is inheriting. You can think about this way. I inherit things, but I also inherit some way to clean those things. So when you call the destructor, you only clean your things, but then you call this destructor that you also inherit, that is the one that is going to clean the things that you inherit. That's it. Now, this is for the delete, but you notice here that there are other two, destructor and derived and base call it. Those are for the object. And I really hope that you have the opportunity to run these programs in your compilers. And if you have one of these compilers and open and close the execution, you are not going to be able to solve those last two. Hopefully you have one that keep the console open, and those are going to be printed, used in this place when the method main finish. When the method main finish, the method main is going to clean the stack, its own stack, and therefore it's going to delete this local variable, an object. Well, here, very important question. Number one, the delete for my Q2 is supposed to happen first because you are literally calling for the delete. You know when this is going to be deleted. It's going to be deleted in this instruction, right? the delete is going to call the delete. Now, if you have more instructions here and the method finish here, it's going to be very easy to notice that this was cleaning, deleted. These two things are going to appear, and then the computer is going to go and do this, and it's going to be easy to notice that when the method finished, the last thing printed on the screen is the delete of the PQ1. However, in your computers, they are really fast and multi-threading and so on. So if you copy paste this program and the last line in the main is delete and also the program is finishing, those two are going to happen. This one first, this one last, but both are sending messages to the screen, and the screen is the video memory. So when you send two things to the screen, things happen there, and this one cannot exactly be in order. But that happens not only with constructor destructors. Anyway, if you have a program that is too fast, or you have a program that is running multiple actions at the same time, usually the video memory gets crazy, and the order of the information that you saw on the screen is not exactly the order in which the information was sent to the screen. So answering the question, yes, when you have these two like too close each other, because the speed of the computer, these two are not necessarily in the order they happen. So for instance, if you print here not only the message, but you print something like an ID of the object or something that helps you to identify which one is one and which one is two, you are going to notice that sometimes they are mixed. Yeah. But that is a problem not in the language. That is something because the hardware, the computer, things there, we are printing things. But this happened first because it's a delete. We know when it happened. This happens second. Now, when you have randomness is, for instance, if here I create my PQ3, question, which object is the first one to be deleted? Which one is the first one to die? Q1, Q2, or Q3? The only one that we can answer quickly is the 2. And why? Because we are killing the 2. The 2 is going to die here. The 2 is going to die with the instruction delete. We always are sure that the 2 is the one that is going to die first. And it's going to die first because the others, 1 and 3, they are going to die when the program ends. And that is in the closing curly bracket. And the closing curly bracket is below the instruction delete. The next question, which one is going to die first, the 1 or the 3? Or which one is going to be second, because 2 was the full one. And next, 1 or 3. Here you have randomness, fully random. There is no relationship between, oh, you create first the 1, so the 1 should die first. No. Both are going to die. Which one is going to die first? We do not know. Think about it. You have the stack, and inside of the stack, you have the stack for the main. And those two objects are, one is here, and the other could be here, or where. We do not know which one is in the top right corner or in the bottom. And moreover, this is just, the memory is a big line. Which one is first or last? We do not know. Moreover, which is the order that the computer follow to clean the stack? Start cleaning the stack at the beginning or start cleaning the stack at the end? It's a decision of the operating system and is related with performance. So you cannot know which one is going to die first unless you call the delete. And that is a second reason, because at least in C++, sometimes it's better to use pointers than creating the object. The first reason is because the memory. The second reason, because you have the control about when it's going to die, and therefore the process that is going to follow. Yes, that is correct. Because remember, if we have pointers, they die when you call the delete. And if you call the delete first for the object 1 and then for the object 10, that is the order. But when you have objects that are not created with new, that are just local variables, they all are going to die when you reach the closing curly bracket. You do not have control about which one is going to die first. Good? Okay, so looks like simple. Inheritance, constructor, destructors. You are inheriting constructors and destructors. Good. Moving forward, problem with inheritance in C++. The main problem. In fact, this one, the diamond problem, is the reason because Java do not have multiple inheritance. This one is the reason because Java decide every single child, only one parent. There are several different cases in which multiple inheritance is useful, but in some point, if you have a parent, person, and that parent have two childs, professor, student, and someone decide to create a class and connect that class to these two, the big problem is, well, if you have this name public or a method, you are going to have name here and also here. You're going to have name here and also here. So this one have two. You can imagine what's happening in the computer when you are inheriting the same variable, and it's the same variable because come from the same source two times from two different branches of the family. And you can be thinking like, well, the only thing that you need to do is to be careful with this. How many times you inherit from the Java API? I mean, you are inheriting JFrame and JPanel. Did you know the family that is above those classes? You cannot be sure, right? The diamond problem. Multiple inheritance and in some point create a loop. Because this, Java remove multiple inheritance. Moreover, because of this, the common sense recommendation, if you are going to be working with C++, is try to avoid multiple inheritance unless you know the full tree of the classes that you are using as a parent. Common sense recommendation. Okay, now, even though I am asking you, do not use multiple inheritance unless you are pretty sure that that is what you need, I need to show you what to do to create multiple inheritance. And well, what to do? Inheritance, colon, but I want to inherit from several. Use the comma. And the comma, the same one that you use for the implements in Java, remember? Implement something, comma, something, comma. And moreover, for each of the parents, you can use the modifier that you want. I put, remember, public is by default. So for this example, I could do my class C that inherit from B, comma A. That is just enough. I can put the publics like I did, or I can change the public for protected or private, and I can use different, protected from one, private from another one. They work. Multiple inheritance. Now, if I am using multiple inheritance, just continue with my example before. Constructor, constructor, constructor. And I have this main, and the only thing that I am doing is to create an object. but I am using the default constructor. Remember that I mentioned this before, the default constructor, the one that do not have parameters. Question in your exam, doing this, the constructor of the class C is going to be called? Yes or no? Common error. The people say no, because there are no parentheses here. Remember, in C++, you do not need the parentheses. If they are empty, do not put the parentheses, it's fine. When you do class C, object C, for sure, you are calling the constructor in C. But you are calling the default constructor in C. Default constructors always, always, always call the default constructor in the parent. And this C have two parents. It's going to call the default constructor, the two default constructors for the parents. These lines here are going to print all of that. The constructor message in the parent B, the constructor message in the parent A, and also the constructor message in the class that I am using. 3 constructors are being executed, all of them. But you do not have the super. You do not have this column calling the constructor of the other classes. I do not need them unless I use a constructor that is not the default, unless I use a constructor with parameters. If you use the default, by default, they call each other's. Very important for your exam, very common error here to say no constructor is being called or to check only the constructor for C. This example, for sure, is going to be in your exam. Please remember, this one is calling these 3. And if you want to review it, copy paste this source code in your compiler and review this before the exam. Good? Any question here? Easy, right? Good. Moving forward, let's make something more complex. More complex. Complex with inheritance. Inheritance is very, very important. And the reason because inheritance is very, very important is because this key idea in object-oriented programming. Probably the most important relationship between 2 classes is inheritance, parent and child. And probably the reason, the most important reason is because that helps you to make polymorphic connections. Polymorphic connections. Yeah, you know what? If you have this class figure and then you have childs, and you have one child that is a circle and another one that is a triangle, you can create an object figure. And even though the object is figure, you can do this new right? Or that is polymorphism, right? That is what you did in Java. That is the reason because this inheritance thing is important. You create an object, parent, and you can do the new, yes, for the parent, you can do new figure, but also you can do news for all the childs. And not only the childs directly connected with the parent, but all the family. Polymorphic behavior. I would like to implement polymorphic behavior in C++. Okay. Main. Polymorphic behavior using these classes, figure, circle, rectangle, whatever. Two objects, one rectangle, one triangle. Good news, I do not need the equal, new, and so on. They are objects, they are calling the default constructors. I want to do polymorphic things. Well, you need, in order to do polymorphic things, one type for the variable and a different type for the reference, pointers. The only way to work polymorphism in C++ is using new. One variable equal to new, something different. And in order to use the new, you need pointers. Polymorphism in C++ need pointers. These two objects here, there is nothing that I can do there. They cannot be polymorphic. They are rectangle and triangle, and I am not doing equal to anything. Automatically, they are calling the constructor in the particular classes. They are in the stack. They are objects. They cannot be polymorphic. However, I can create pointers. I can create pointers like figures, like these ones. And the pointers, I can point anything. I can point anything, like I can make my pointer equal to the address of the other objects. Or also, I could have done a new and use the other classes. Both are the same. The polymorphic one is going to be the pointer. The pointer is the one that can point to any of the child classes. Good. Now, polymorphism, I need pointers. Check. I have my pointers here. I have this rectangle and triangle. I have this F1, F2. And you know what? I am going to print what happened when I call a particular method from rectangle and when I call that particular method for triangle. These are the methods that are going to be called. And this is what is going to be printed. And then I am going to do exactly the same. But now, instead of using rectangle or triangle, I am going to use the pointers, the figures, figure 1 and figure 2, and I am going to use the arrow, and I am going to call the methods, and I want to see what happened. Theoretically, if I call F1 area, just because F1 is pointing to rectangle, this F1 should be the same result that the rectangle area. And if I use F2, just because F2 is pointing to the triangle, this result should be the same one that this one. So theoretically, I am doing 2 times the same, calling the area for rectangle and triangle, and then the same, but using the pointers. At least in Java, that should be 2 times the same result. That is my output. Okay, let's see. Area for rectangle. The area for rectangle is something like, I said these numbers and these numbers. So the area for the rectangle is this method, is a multiplication, and basically multiply these 2. That is happening here. And this is the result. Okay, I think it's correct, the area for the rectangle. I have my object rectangle, I call the method, result is correct. Then I call the area for the triangle, and this is my result. I am calling this area here, and that area is with these numbers here. And if I do the multiplication and then the division, yeah, 600. This method was called with these numbers. This is correct. What happened with the pointers? Why they are giving me 0? They are giving me 0. and I haven't changed the values. So the values are not the problem. If they are giving me 0 with the same values, they are not calling this method. They are not calling this method. Here is a 0. They are calling the area in the figure. They are calling the area in the parent. Wait, you create an object, and that object is a rectangle. And you create a pointer, and the pointer is figure. But you connect this pointer with this object. I mean, this is what you did here. This is the address of the rectangle, storing a pointer. But I am calling from figure the method area. And it's not calling the method in the rectangle, it's calling something else. It's calling the method area in figure, but I am not using object figure. Figure is the pointer, and it's pointing to something else. It's calling that one. And that is the reason for my zeros. This is not polymorphic. The only thing that you did was mixing the pointer with different things. And a pointer can point to anything, but you are not telling me that you want polymorphic behavior. Slide 1, slide 2. Did you notice something changing there? Okay, the only thing that you need to do is to put this word in the class that is going to be polymorphic. Why? If you put that word there, you are telling the computer that even though you have a pointer that is from that class, if you are asked to use that method, the first thing that should happen is go and search for that method in the childs. And if you found the method in the childs, use that one instead of this one. One word, guys, virtual. The key for polymorphic behavior in C++. If you put that word there, this is your result. Using the objects, using the pointers, exactly the same. I can use the pointer to the object, I can use the object itself. The pointer is figure, the object is triangle or rectangle or whatever. Polymorphic behavior, even though I am a pointer to figure, I am going to behave as a triangle or as a rectangle. But you need to tell. If you, for any reason, forgot virtual, if for any reason you do use the process that you follow in Java, use the inheritance and that's it, not polymorphic behavior, use the usual. This is a figure, calling the method in figure, not in the childs. Clear. Question in your exam, I give you this, or I give you this, and I ask for the output. Polymorphic behavior, that is fine. Next, moving forward. One last thing connected with this. Something that you can do in C++ that you cannot do in Java or in some other languages is overloading of operators. Overloading of operators. I have a student. It's an object. It's another object. What if I want to do object 1 plus object 2? What if I want to do object 1 plus 10? What if I want to do this object divided by something? What if I want to do an object model another one? What if I want to compare which one is greater? What if I want to ask for different? You have something like this in Java only with one operator, the plus. You can use the plus to add strings, even though the strings are objects. But you cannot use the plus with other objects. What I am showing you here is you can use any operator with any object. Obviously, the question is, but what is the meaning of this? You define the meaning. In C++, you can think about operators like methods. I can think about having a method increase grade that receives as a parameter the 5, like increasing the grade of this student. X is a student, 5 points. Instead of having this method, what I can do in C++ is overloading the plus and make this equivalent to this. So the plus for students is going to be increase the grade in that number. Why should you want to do this? Only one reason, to make your programs smaller. An operator is always small, one character, instead of a full name of a method with parameters. The idea is to make your programs look better. Overloading of operators. Okay, the question is how we do this. This works with any class, and I am going to give you an example. Think about this. I have a class, and first I am going to show you the main, and then I am going to show you the source code. But think about this. I have a class, and I am going to use my class in the main method. And this class is my class cylinder, a shape. And I have these objects, cylinders, and I want to work with them. Work with them. Well, in order to work with them, I call the methods in the class. And you can imagine that my class is going to have this method set for a variable radius, this method set for the height. So far, all this, nothing new. One class with setters, I am creating objects, calling the setters, everything normal. I can also do this. I can use my objects to call a particular method that is a getter, but it's going to calculate something like the volume, and it's going to return that to another variable that in this case is this double variable. Calling a method, the method returns something, do something inside, common things. If I want to add two objects, option number one, I could have a method like cylinder one is one of the objects. Add with, and I can send the second object as a parameter. If I show you this one, you can be thinking like, okay, that one is a public method. The name of the method is add with. It's going to receive one parameter, and that one parameter is going to be from cylinder class. It's going to receive as a parameter one object. In Java, one object. In C++, probably you would like to think about this one like receiving a pointer or receiving a reference. Remember reference, right? In any case, this one could be your usual solution, a new programmer solution. You can, instead of doing this, the only thing that you need is, instead of giving your method this name, add with. Somehow, we need to give your method this name, plus. And if you notice the parameter, the second thing is the parameter. The first thing is the object calling the method. So you are telling me that this kind of having cylinder one dot, and if I use as a name of the method plus, wait, that is going to be a lexical error. We need to solve that later. But if I use the name of the method plus, then I can pass as a parameter something like this. This one become this one. Well, wait, if you're using this, can we ask the computer to eliminate this dot? Because the dot before the operator look bad. I mean, if I have the operator, why do I need the dot? It's obvious that before the operator, I have the object. And if I can eliminate the dot, can we also ask to eliminate the parentheses? Because if we do that, we have this cylinder one plus cylinder two, instead of cylinder one dot add with parentheses cylinder two parentheses. That is exactly what is going to happen. And I can do that with the plus, and I can do that with the minus, and I can do that with this greater than. Those, the operators with the cylinders, they have no meaning, but I can provide a meaning. I can do the overloading of those operators. I am using as an example the plus, the minus, and the greater than. You can overload many others. Okay, looks good. Again, use fancy things. You can do the things like in the blue sentence, or you can continue working as usual with the red ones. You want the fancy ones? You want these blue lines to work? Next step, my class cylinder. My class cylinder is 2 slides. So slide number 1, I am going to work with a new library, CMath, and I am sure that you can guess what I am going to get from there. That constant, the value of P. Anyway, that is the only reason for that library. My class cylinder, private, the variables, public, the methods that I used before, getters for volume, that is the one that is going to calculate things, the setter for the radius, and the setter for the height. So far here, my class look normal. The class open here, but I haven't closed the class. The class is going to close in the next slide. The next slide, these methods are inside of the class. The methods, overloading of operators. What is happening? Well, you want to have a method that is called plus. You cannot use only the plus, but you can do something like this. Operator plus. We're going to need to call the method as operator plus. No, you're going to call the method just like plus. The only reason because we put operator, that by the way, operator is a reserved word, keyword here, is because in that way we avoid the lexical error. Operator plus, and operator minus, and operator greater than, an operator, and whatever operator you want to use as the name for your method. Then parameters. If you have an operator that is binary, you only need one parameter. That parameter is whatever you have after the operator. What do we have before? What do we have here, here, and here? The method, the object that is calling the method. Make sense? Think about it. Here, cylinder 1 calling a method. Cylinder 1 calling a method, plus the second thing is a parameter. Cylinder 1 calling a method. The second thing is a parameter. Cylinder 1 calling a method. The second thing is a parameter. This is the object. Only the second thing is a parameter. One parameter, one parameter, one parameter. Always, always, always the parameters for overloading operators, they are going to be like this. Do you remember what is the meaning of that? The ampersand when you are creating a variable, in this case, the parameter. What is that? It's a pointer? A reference. What is the difference between a reference and a pointer? Question in your exam. With the pointer, you can play and increase or decrease the pointer in order to point to an address before or after. With the references, number one, you cannot do that. So you have less freedom. But the important thing, here, you are receiving an address, a pointer, even though here, you never mention an address. You put there the value, you put there an object. When you send here, you receive the address. We play with this using integers, remember? An integer variable, I send the variable, but I do not receive the variable. What I receive is the address. We review references. Apply that to objects, and in particular as a parameters here, and you have this very clean way to work with cylinder 1 plus cylinder 2, two objects in my class, and that is just calling this method. I am using operators as names for my method. And the only reason is, again, make my program look fancy. If you want to change the name here and put add, that's fine. Minus, compared to. But look better if we do this. Now, the only thing is plus. The operator plus need to return something. All the operators return something. Cannot be void, but you can return whatever you want. For instance, you can return a cylinder. Makes sense, right? Cylinder plus cylinder, another cylinder. Cylinder plus cylinder, another one. The same for the minus. And if I think about this one, relational operators. What is the return value for relational operators? Something greater than something, something lower than something, something equal to something. All the relational operators return a Boolean value. By the way, remember that we talked about bool is back the Boolean values in C++. Operator greater than, return a Boolean value, receive as a parameter one cylinder. And what is going to happen here inside is I am going to compare the value of the current object with the value of the one that I receive as a parameter. Do you remember what do you do in Java when you want to use the values of the current object and compare with something else? What happened in Java when you have a variable x parameter and a variable x that is part of the object? Do you remember what do you do in order to identify one from the other? A keyword. Do you remember that one? Mm-hmm. Only one thing happened here. This, I am calling get volume from this object or get volume from the one that I am receiving as a parameter. I am going to compare which one is greater than this. And the only thing that I do is calculate the volume of one, the volume of the other, and then do the comparison of the volumes. Only one thing, this in C++, this is a pointer. And well, because this is a pointer, every time that you want to use this, you do not put the dot here. Every single one that you want to use this, like in Java, you use the arrow because it's a pointer. And that's it. Homework, guys. Full source code for my class, full source code for the main. Play with this. 3 operators overloaded. And a second example now with days and other operators. Play with this. Any question we review in the next lecture. Good? Okay, very good question. And to close, I am going to go to the last slide and I am going to tell you this. Number one, no, you cannot overload the ternary operators. In fact, this is my ternary operator. Remember the question mark for the conditions? You cannot overload that one. Also, you cannot overload the scope resolution operator. Also, you cannot overload the dot with the asterisk, the one that work together for the pointers. And also, you cannot overload the dot. So, operator dot do not work. But you can overload all of this. And if you want to play with something, delete is an operator. You can overload delete. And a lot more. All of them are binary, worst case scenario, but several of them unary. And obviously for the unary, like the plus, plus, minus, minus, something that you're going to notice is for these guys, they are unary, they do not receive parameters. You have the object that is calling the method, no parameters, and that makes them to be unary operators. Good? Okay, guys, I am going to stop here. See you next lecture. Please review this. Thank you.